I'm from Ottawa in Canada, and I've contributed to the framework. I worked on the RPM, FPM packaging initially, and have tried to help a bit in whenever Kenneth needs something done in my time zone, which is like Kenneth working very late, and then right at the end of my day, I can review something that he's working on way too late at night. Uh, I'm just going to go through a few things. Sort of what I've seen. We went to FOSDEM this week, sort of seeing the broader perspective outside of HPC, how software is being used, or how machines are being configured, DevOps, I guess you might call it, and how that might integrate in to our environments. I'm not going to talk all about that, but I'm kind of inspired by that to talk about a couple of the other things that we use within HPC, but is used outside, like Conda, say. Talk a bit about that and Nix. I've been working a bit with them and using them with EasyBuild and talking about sort of the peculiarities of that and the problems that they're solving. So, what happens to me a bunch is that users come and say, I've got this thing, it's from some journal, here's the URL, just get it working. And in my domain, it's usually bioinformatics software, which means that it's not going to work at all the first time, and probably maybe ever. So, we have the same problem of dependencies being all over the place. This is something that we use EasyBuild for to handle all this dependency sort of problems, but none of these are satisfied by the OS. And, what we see in parallel communities to the EasyBuild community, things like Conda, they're solving the same problem in a slightly different way. They want, they want to control some of these variables, but they often don't control the environment quite like we do. And that's kind of what we're going to contrast. So, one of the things, the path is something we all really understand. This is what the user, usually we don't want them to go directly to the binary. We want to set that path for them. We also set things like man path, LD library path. And then what's kind of specific about the use case of EasyBuild, and something that I just want to highlight when you're comparing it to something like Conda or Nix, is that they don't necessarily set up a development environment. Like sometimes they will, but a lot of cases they expect that if you're going to build another software that depends, say, on Nix dependencies or on Conda dependencies, you would handle in their way getting those dependencies, the variable set, whereas in EasyBuild, the things like the C path and library path are often set for you, and they're ready for developers to then take the library and use it further. So when we're looking at RPath, is anyone using RPath here for anything yet? In EasyBuild or otherwise? Are people familiar with RPath? Let's go back to that. Sort of. Do people want to know about RPath? So I think that, if you look at part of what I'm getting around here is saying we have kind of, say, Nix and Conda as two examples of other sort of within the domain solutions, have used RunPath, RPath, and in order to solve kind of the same thing, but in a different way. And I guess understanding why that's used is what I'm hoping would help you understand where you might use RPath with EasyBuild, and also why these things are different. So one of the things that is both Nix and Conda, just going back to them, building is slow. So what do we do with building? We know this building is slow. We've done it. Package management, binary installations, this is how OSs are installed. Why aren't we all using FreeBSD or compiling everything from scratch at the beginning? Partly because we want it to actually show up fairly quick. So both Conda and Nix actually allow you to install binaries instead of compiling it locally. They specify how to build it, and you could build it, but normally you're downloading a binary. And this is one of the things that we don't do with EasyBuild, and maybe something that we might want to do, and something I've played a bit with as well. So Conda supports relocation. So what's that mean? I guess Kenneth talked about the origin variable. Did people catch that? Maybe with RPath, if we're not super familiar with it, origin allows that wherever the binary happened to be, that variable is filled in, and then you can relatively find the library. So in Conda, wherever the binary would be. That would be a bin directory in somewhere in your tree. The libraries are .lib, .lib64. They're there. They're right next to the binary. So that means that you can install binary packages without rebuilding them. So you can go and grab a binary package, put it somewhere under your home directory, run a binary from that, and it be able to find all of the shared libraries it needs. I see confused faces. No? Okay, that's just that's just the So I think that when we think about the problem that we have with HPC's way that we install things, we like to keep everything separate, but this adds to some challenges because we have the loader, the dynamic loader isn't making it easy for us to find these libraries. So then we have to do things like LD library path. Like this is where we get into the mess of modules and LD library path. And I think that sometimes when we're at FOSDEM explaining why HPC is weird, it's hard for us to explain that this use case and user's experience is important and that it works this way, and that things like Conda can work as well, but it works differently. Things that are missing from Conda is these are all binary compiled for the most part. You could recompile them, but they're not necessarily optimized for architecture. They do handle optimizations for architecture, but they're doing it more in the generic way where they'll have fat binaries or MKL or something that's installed that is able to handle all of the architectures for you without you having to install or without you having to compile it locally. So here we go. This is the Conda version of LDD, so you can see how it resolves. It's at visible. It's maybe a bit small. But you can see how it resolves where the libraries are for just something like Python, where the main Python binary mostly loads from libpython. You can see it just goes one directory back from the bin directory, finds the library and the shared library path. And in Conda, it's still using all of my system libc, which is significant in other cases, but something to talk about. So this is the elf header. This is where the work is done. And you can see the R path. So in Conda, the only thing it has to set is in this particular binary, because all of them are under lib, is that's the entire R path. So I don't know, are people using Conda in their environments at all? Are there users using Conda? Do you have, I guess the thing is, the one nice thing about this is the users don't have to talk to you. If they have rights if they have permissions to write to their home directory, they can install libraries and shared libraries without talking to sysadmins. So that's one of the reasons you're seeing this used a lot in HPC, whether or not it's optimized for the environment. So that was one of the things going back to how EasyBuild is going to handle this. It's a little bit more difficult because the libraries are all spread through various directories. So the R path now, if you look at it from an EasyBuild build, is a very long path of each of the various dependencies, and right now it's a bit naive. It's not really aware of which dependencies are needed or not. It just takes the safe option of just including everything, right? Like it includes all of the various paths and then the origin back as well. So this is a big blob, but the Nix is a bit different. It likes to put everything more like EasyBuild. It puts it in the store. So now instead of you need to have root at some point to put it there, you could recompile everything and put it somewhere else. That's also supported within Nix, but that's the way that they prefer to do it. But it has some other side effect features, like you can build things in containers and that. So I was going to show some examples on just that I have from. Let's see what I had. I was going to try to show a singularity example with my container, but I was having problems. So so right now this is outside of the container and then running into, this is Docker, but as a user I now have an environment and then can build with EasyBuild like this, and then I should be able to get this working under singularity as well. The other one of the things for Docker is being able to run things without the entry point, ideally. So you can run things, but you can run things with just a command. But I'm having trouble with my shell environments. This is one of the things that is a frustration for us in HPC versus what you would see in other environments, is because we're managing a lot of shell variables that we end up with funny bugs in LMOD that then come out. I'm not really sure like what other interesting things there are. I had another kind of example of binary package installations, but what sort of things are people interested in? What are you looking for as far as EasyBuild, or as far as what's the next step feature that you think is missing in EasyBuild? Like, is binary packaging interesting to anyone in EasyBuild? Right now, if I said to you I could give you binary packages from somewhere else, you could install it in EasyBuild instead of building something. Would that ever be interesting? So that's something like I've been working on a bit, because in my environment, and especially when you're going to build things into containers, if you want it to be reproducible, I don't want to have to build the entire tool chain again in order to build the next thing on. So I build packages that are available, but if I'm going to do it, or there's going to be other people testing builds, it's nice if there's a single repo of generically compiled GCC, the basic things that we use in this example. I use /EasyBuild now as the kind of a store. So I put everything in a place that I hope that on every cluster or container it would be reproducibly used. Do you have the microphone? Just let me. We got the microphones working now, so we can get the.
Okay, one thing.
It's on. It's just you won't hear it, but it goes into the.
It's okay. All right. So one thing that I have applied FPM with, which is an interesting trick, is you can deliver an RPM that lets under DevSHM things to live. In fact, I deliver EasyBuild in that way, because that makes EasyBuild commands very, very fast.
So that's what Photos suggests here, is abusing DevSHM. So many clusters will allow you to write into there, and providing you have enough memory.
Yeah,
you can put an EasyBuild.
It should work all right, but outside of the container, only the sysadmin can allow a policy like that to happen.
No, anyone can write into DevSHM.
But it's an RPM, the delivery mechanism. Okay, you can.
No, the RPM. That's the other thing I've shown in the binary installation that I have for EasyBuild. I wrap EasyBuild and shove. I install binaries in the same place. I use an alternate database path, so it doesn't require root. As a non-root user, you can install RPMs. Because I don't use the root database.
Yeah, and building on this idea as well, the slide you presented before about Conda, maybe that could be a convenient bootstrap mechanism for people that that are first timers. You could deliver in this way under DevSHM some basic substrates of Python, EasyBuild.
Yeah.
Who knows? Maybe you can even do a hack with the compiler itself, and then get an environment that's really ready to be used on several systems.
I mean, yeah, I'm curious about. That's a good thing. That's. I mean, this is one of the things. Like, if Singularity is around and more used, then there's a possibility that, we'll get. Then you can more easily install the tricks that you're talking about, because Singularity can handle wrapping that CH root. Basically, it has a sysadmin approved way of changing your root. And that's one of the problems. I'm now compiling into like 4 or 5 different clusters where I'm not sysadmin on any of them. And the problem I have is that every space their scratch directory is mounted somewhere else, and I've got to rebuild everything. So that's why binary packaging for me is starting to become more interesting, but in a way that I can somehow change the root. And DevSHM is a pretty nice way of doing it. I don't know if anyone at IRC had questions. Maybe Ward is.
So the binary packaging is very interesting to. Yes.
Are they saying they can't hear you?
Right. So I guess it's. So it's very interesting to set up a test environment, like you say, quickly install the tool chains, and you don't have to rebuild from scratch, because that takes a couple of hours. But I'm not sure if it would be useful beyond that, because one of the reasons we're using EasyBuild is so we can compile from source for the target architecture that we want to run things on.
Well, and also the target path.
Also the target path, yeah. So maybe it could be used for local caching if you want to re-roll out your whole software tree at the same location, at the same architecture for some reason. So maybe for people that want to do local installs like you do at TAC, you want to install the software to a local disk rather than a shared file system, then it would be...
Well, I have the opportunity here because I'm running it in an environment where I would know, you could specify the architecture. So I could go and grab like AVX2 compiled binaries as well.
Yeah,
if you said
but
that was...
Then you have to compile for a gazillion architectures.
Well, yeah, except that if I can say I'm only compiling for one path at least, that's a lot more feasible. Because you can do 3 or 4 architectures, like even AMD, AVX, AVX2,
And
something like that.
combination with the OS probably as well.
Yeah,
Like
it's a good
if you're on
question.
CentOS 6 or if you're on Debian, you're going to need to redo this whole thing.
If we can get a... Yeah. So, I mean, that's the I guess the Nix option that Compute Canada is talking about, which I had problems getting working. But there is some interesting discussion about now you can provide a libc and a whole bunch of the
Yeah,
dependencies.
this is
that way.
something we'll be discussing with
Yeah,
with
we'll
Bart
see.
tomorrow.
I'm looking forward to hearing that.
Yeah, so do I.
Yeah, I'm gonna I'm more interested in hearing if people have questions and stuff, and then we'll wrap up somewhat early. I didn't really have a strong plan of what I was doing. Too much beer. Is there any? Yeah.
Would it be feasible to somehow combine your container building with DevSHM and the job backend? So maybe it might make it more feasible to run more comprehensive tests when you're building.
There's no reason that
See
you
what I
couldn't
mean?
use the RPM building is compatible with DevSHM, or sorry, it's with the job submission. And if you make binary, like a binary step, if we put that into the core somewhere as an option, then at least the node could go and find it. And it could be local. Like I'm just using an HTTP request to grab the RPM, but if the RPM happens to be in the source directory, like the standard EasyBuild source directory, I just put it in the same spot that the tarball would have been. If the RPM's there, it'll use it from there, and then it'll install it. So you could do, like you're saying, for a submission in a place where you may or may not already have the full stack. If the RPMs are there, you could do it, or if you already have it in, because that's DevSHM, you're not going to see it, and nothing's going to be there when you're going to start your install, right? Your build. So whatever build you're trying to do, say be like something dependent on FOSS, you're not going to have anything else that's already available in that because it's memory. So you can do the RPM installs quick because you can get the RPMs installed there in like a minute or less. And then you can go and build whatever piece of software that's an extension to that, write the package out to some place that it can be reused. Like the source, you could write it out to the sources directory. And that's like mine, I just use that. I go and fetch it if I can't. I use the same code, like the fetch code, the same as EasyBuild uses now, and use the same thing to basically as a sources say, is it there? And that's an option. I just, like when some of these things may not have enough of a use case to ever bother doing, so I don't have a lot of time, and I don't, like, there's a lot of things I can do that I can avoid doing this, so. Yeah, I mean, it's sort of a difficulty with having a very broad, familiarity with EasyBuild too. Like, I tend to talk about things that are very, very narrow use case, I guess, versus, some of the more general stuff we could talk about, so. There's nothing else that we can... Oh, has he got something? Yeah, downloading, so he's got, why not providing containers instead of binaries? So actually FPM supports writing out a container as you can take a directory and write, yeah, you can write out their format too, especially, EasyBuild, one of the things, so something that happened out in the wild, Nix did composable containers, because one of the side effects of having a namespace that's separate for every package, so in Nix, and same with EasyBuild, is that a package only starts at a root, store, package name, version, everything is separate. So that tar is all completely independent from it. So they're independently composable, and the same somewhat with EasyBuild. They're independent. Nothing should conflict with something else. That it matters that anything layers. So to create a Docker container out of EasyBuild is trivial because it's just the tarballs of the things that are, because there's no overlap of those things. So then you have this opportunity of just basically, instead of having an RPM that you're stalling to do the same thing, you can just pub the raw layer, and then you can say out there, I want to go get this target layer, and it just gives the list of the tarballs in some order, doesn't matter, because the layers are all independent, and then it creates it. So a Docker registry, all it is just a manifest list of tarballs, basically, and then their tarballs have an extension to layer one on top of another, so when something's deleted, they can actually remove it. That's one of the extensions. So, sure, you could build basically layers as opposed to full containers.
That's the approach that would not work with Singularity, I think. Where's Michael? Yeah. I mean, the layering, the Singularity support that too?
But they can consume it. And Singularity supports a local repository, so you could set it up in a local repository, just shove all your tarballs into that. You have the checksums come out, you just grab the manifest of things that are interesting and then shove it in, sure.
So you
don't even have to store all the different, all you have to store is the layers, and the layers are just the various packages.
So you could have a Singularity, correct me if I'm wrong here, you could have a Singularity bootstrap file that just pulls in different Docker containers that layer on top of each other.
You just have to have some name for you have to have some way of finding the manifest of that, some way of naming it, but EasyBuild already has names for things, so sure,
exactly.
You could create a canonical name for some set, and then those dependencies would be resolved by sure.
Yeah, okay.
That's it. I mean, it's an interesting idea. That's something to, if people had a lot of interest in doing containers. I mean, the problem that we have with EasyBuild in containers is it's very shell heavy. Maybe if we build them with RPath, it'll work. But right now with LD library path, one of the things that makes Singularity work right now, and Michael said it's changing, but that is the scheduler and MPI work partly because the environment is the same in the container as this is not how Docker works. Typically it wipes your environment. So now they're talking about wiping the environment and bringing only certain things in, but now you have to have a lot more nuances to what is available there in order that the scheduler and MPI work. So that makes it a little bit more complicated because, anyway, LMod tends to be a bit of a heavy tool for this kind of stuff too within. When you know where all the libraries are already, we could just RPath it and then. I don't see anything else there. All right, thanks.